All right, good afternoon, everybody. So I've got another observation for you. I was going through and trying to charge my batteries from the grid while the inverters are set to solar utility battery mode. I actually wanted to run a test to see what the response was from the inverters when the batteries were up to 100% while in solar utility battery mode. And I ended up having a completely different test taking place. So I want to show you what I saw, what I discovered, and share with you just these oddities and see if anybody else has actually experienced any of this before, if anybody understands why, because it doesn't make any sense to me whatsoever. So let's get started. So I wanted to run a grid charging test. My batteries are currently at around 80 some percent, 84 I think. You can see my phase 1 inverter, strict bypass. My phase 2 inverter is charging from the grid. So I went in and I changed the setting because I wanted to see what solar utility battery mode does when the battery's full. So I'm recharging it from the grid so that I can get the battery voltage up faster. And so this phase 2 inverter, if we look at the settings, go to option 16. It says SNU, which the manual says SNU is solar and utility charging. So we look over here at phase 1 inverter. Go to option 16, and it's S0, which is only solar. So if I change this to SNU as well, and both have a charge cap at 50 amps for option 11. So I'll show you that over here as well. Okay, so battery voltage right now is 54 volts. So it's not quite near, I don't remember where I have it set, if it's bulk charge is set to 56.8 volts. So that's what it's supposed to charge up to. So now you hear that fan change. So since I made that, the phase 1 inverter is now ramped up, and now it is charging at 50 amps on phase 1. Now it's dropping down to 34. But if I come over here and I look at the phase 2 inverter, nothing. And yet the battery voltage is 54 and the bulk charge is set to 56.8. So it seems like it's trying to be smart in the fact that it's only charging a little bit 30 amps when its max is 50, and yet it's kind of causing a phase imbalance because it's not charging the same from both phases. So it's just pulling nothing over here and 32 over here. And now here's, if I come in here to my phase 1 inverter and I go to option 16 and change it to only solar, and notice these icons. You see the battery, the arrows pointing from grid down to the battery. Now it's going to ramp down on phase 1. And phase 2 is now going to pick up where phase 1 was. And charge it 20 amps. So with the two inverters communicating between each other with the parallel cable, why are they not equally pulling the same amount of power from the grid as to not cause a phase imbalance? I don't know. Just an observation that I've made. And the other thing is, the inverter, the voltage is at 54 volts. So why is it slowing down when it's supposed to be bulk charging up to 56.8? I think is what I had it set at. I don't know. Just another oddity. So I was trying to figure out why the voltage wasn't changing and going above 54 volts. And for some reason, this option was being triggered. Option number 27. Float. It was stuck at 54 volts in float when it never even got up to its bulk charging voltage of was 57.6. So I don't know what's going on. It's like float voltage was taking effect before the bulk charge voltage was hit. And as soon as I did that and changed the float voltage up, now both of these inverters kicked in and they're charging at 35 amps. And this one's charging at 50 amps. Very annoying that the float voltage is coming into effect before the bulk charge voltage is. Alright, so here's what's going on. I'm going to do this on the phase 2 inverters since it's easier to do this on one. So right now, no power going into the phase 2 inverter, or no power being put in from the phase 2 inverter. Battery voltage 53.9 volts. Putting in 972 watts. And again, nothing from this one. So not quite 54 volts. Utility should be charging at 50 amps. Charging with solar and utility. The bulk charge voltage, 57.6 volts. Again, we're at 54. Float voltage, 54. If I change the float voltage to 55, .54 volts on the battery. Now you hear the fan start to ramp up on the phase 1 inverter. Now the phase 2 inverter is ramping up too to put in 55 volts. So why is float taking priority over the bulk charge voltage? So I wanted to run a test on what happened with the battery getting up to 100% when grid charging. So you can see I started this around 2:42 on Sunday afternoon, and based on the settings that I had it set for, everything ran fine. It ran, I want to say, close to 50 amps on both inverters. No problem. And then I was leaving the house, so I ended up turning it off. And so you can see it just ran regular grid supply or grid bypass for a few hours. Came back home, and just before 8 o'clock in the evening, I wanted to turn it back on to try and get the rest of that battery power and get it back up to 100%. And when I did that, I was noticing that, like what you just saw, there was not a whole lot of power being actually put into the batteries. And you can see that here. You know, 2,200 watts between two inverters. And then you can see here the time that I changed the float voltage. And it jumped right up. And then I had turned it off. And this is the last clip that you saw where I had turned it back on to where you could see that it ramped back up. So I just wanted to show you that throughout the day, the battery did not hit its voltage. And I can come down here to battery voltage so that you can see that. 54, 54, 54, 54.5. Never hit its 56.8. And right in here, when it got turned back on, it still hovered at that 54. And then I made the change to float to bring it up to 55. And then I did change the float to get it all the way up, 56.8. So yeah, that battery voltage never hit its... And I don't know what this style inverter calls it. I know I keep saying bulk charge voltage because that's what was the terminology used from the Victron's charge controller standpoints, but it's the charge voltage set that it's supposed to get up to and then basically stop charging until your voltage drops down to your float voltage, and it's supposed to maintain around that float voltage. At least that's my understanding. But even still, you can see in the battery voltage, it never got to 56.8. In fact, got my battery state of charge up to the almost 100%. But yeah, this boggles my mind as to why it's doing this. And not to mention, let me see here, battery current. So you can see in my test earlier in the afternoon, inverter 1 and inverter 2, 49 amps a piece. It stayed consistent. And then you can see inverter 2 supplying all the power here. Then I made the change to have inverter 1 do all the charging. And inverter 1's doing all the charging. Now inverter 2 is doing all the charging, but it's an imbalance. You're putting in 30 amps on one phase. And then over here, now you can see where it starts to, where I switch the float voltage. Now both of them are starting to pump in. Still not exactly the same amount, which again doesn't make a whole lot of sense to me because they're in parallel. They should be in communication. So you saw in the clips that I recorded the different problems where the inverters seem to be charging at different rates, which didn't make a whole lot of sense to me. You can see that the inverters didn't seem to actually charge up to their bulk charge voltage, which again didn't make any sense to me. And then I went through the solar resistant logs and showed you the battery never got to its maximum set voltage. So there's no reason why the inverters should have been abiding by that float voltage at all to maintain the voltage at 54 volts when it never got all the way up to 56.8 volts. So whether or not this is going to be a continuous thing, I don't know. I'm not going to be using the grid charge. I want to recharge my batteries from solar. It kind of, in my mind, it kind of defeats the purpose to take power from the grid to put it into my batteries when my entire goal is to save money by skipping the grid altogether. So taking power from the grid and dumping it into my batteries, well, I'm spending money for that power only to save it for later. So that doesn't make a whole lot of sense to me. The only time that I see myself actually using the grid charge is if I know we've got some really severe weather coming in and my batteries are at a lower state of charge that would not allow me to maintain power in the event that we had a complete outage. Overnight, over a couple of days, whatever. But that's probably going to be the only scenario I can think of where I would ever want to charge from grid. If any of you have seen this before or know, am I missing something? Am I misunderstanding how this is supposed to work? Let me know, because from my understanding and the way that I ended up using all this stuff from the Victron charge controller standpoint, the inverters are supposed to charge your batteries up to that bulk charge voltage, max charge voltage. I don't even know what the manual calls it, but 56.8 volts. It's supposed to go up to that voltage, and then it stops charging for a while. and your batteries are supposed to basically deplete down to your float voltage, and your inverter is supposed to maintain that float voltage for a set period of time. And again, I don't have the manual right in front of me, so I don't know what that set period of time is supposed to be, but that's my understanding of how it's supposed to work. All right, just another oddity that I wanted to share with you guys. I have some clips that I'll be doing another video of, just a handful of different oddities that I've noticed as we use these inverters to power the house. I'm going to try and put all of those together into a single video to share, just so that you can see some of the different things that I've been experiencing. Whether or not they happen once, whether or not they happen multiple times, it's still an oddity that in my mind shouldn't be happening, but I figured I'd share them anyways. So, y'all have a good afternoon, and we'll catch up with y'all later.